Hey everyone, welcome back. So in this video, we will try to answer this simple question: should you play Powerball? So if you haven't heard about Powerball, the Powerball is an American lottery game offered by 45 states. And since October 7, 2015, the game has used a 5 out of 69 white balls plus 1 out of 26 Powerballs matrix from which winning numbers are chosen. And each play costs $2 or $3 with the power play option. And it offers various prizes for matching 1 to 5 white balls or the Powerball itself. And the jackpot could make winners instant millionaires. So the question is, should you play it? The author Jordan Ellenberg made 3 points in his book, How Not to Be Wrong, The Power of Mathematical Thinking. And the first point is, don't play Powerball. Okay. The second one is, if you do play Powerball, don't play Powerball unless the jackpot is really big. And the last one is, if you buy tickets for a massive jackpot, try to reduce the odds. You'll have to share your haul and pick numbers other players want. And don't pick your birthday, and don't pick numbers that want a previous draw, and don't pick numbers that from a form a nice pattern on the ticket. And for God's sake, don't pick numbers you find in a fortune cookie. We will focus on the second point, and we'll try to calculate how big does the jackpot has to be to make it worth playing. To answer this question, we need to introduce a new concept, which is expected value. The expected value describes the average outcome or mean of a random variable over a large number of trials or occurrence. It provides a measure of the center of the probability distribution of a random variable. For a discrete variable, here is how you calculate the expected value. So you sum all the possible outcomes times its probability. And for continuous variable, we need to do an integral of x times fx. Here's one example. So a fair six-sided die has 6 possible outcomes, each of which is equally likely to occur. The outcomes are the numbers 1 through 6. What is the expected value of the die? So here is how we calculate the expected value. So we used all the outcomes, or the possible outcomes from 1 through 6 times its probability. And because it's a fair six-sided die, so the probability for each number is 1 over 6. So 1 times 1 over 6 and plus 2 times 1 over 6 plus until plus 6 times 1 over 6, which is 3.5. What does 3.5 mean? Let's simulate this scenario to understand it better. We roll the die for once and calculate its mean. So for example, if we get a 4, and then the average is 4, and then we roll the die again, and for example we get a 6, and we calculate the mean, 4 plus 6 and divided by 2, which is 5. Okay, and we repeat this process for 1,000 times. As we roll the die more, the average gradually gets closer to 3.5. So now we increase the number of rolls to 100,000. The average become almost identical to 3.5, right? So this illustrates what 3.5 means in terms of die rolls. So in the long run, the average value of the outcomes converges to 3.5. And this also demonstrates the law of large numbers, which states that the average of the results obtained from a large number of independent identical trials should be close to the expected value and tends to become closer to expected value as more trials are performed. Now let's get back to the Powerball. So here are the odds of each prize I get from their official website. So for the grand prize may vary from time to time. For the grand prize, the odd is 1 out of 292 million. Okay, so for 1 million, the odd would be 1 out of 11 million. Okay, And for $4, that's 1 in 91.98. And for this just Powerball match, and it's $4, and the probability would be 1 over 38.32. So the Powerball jackpot right now, as of December 4th, 2023, is estimated to be 412 million. So let's calculate expected value for the Powerball. So we get prices and we get odds, and then we sum prices times odds. So the expected value for the Powerball ticket is 1.73. In the long run, the average value for a Powerball ticket is only $1.73, which is less than 2. So what is the minimum jackpot to play? So let's assume the minimum jackpot is Y. So Y times is odd, and then plus the sum of the rest of the prices times their probabilities. If this expected value is greater or equal to 2, then it's worth playing. Otherwise, it's not worth playing, right? So we solve this equation from in R, and we get the minimum jackpot is 490 million. So if the jackpot is more than 491 million, then it worth playing, but it doesn't guarantee that you will win the jackpot or any prize. It just means that the ticket is worth more than $2. So that's it for this video. And in the next video, I'm going to talk about some interview questions about expected value. So stay tuned. If you find this video helpful, please like and subscribe. Thank you for watching.